Welcome to this episode of Nurturing Excellence, Teachers of IIT Kharagpur. Myself, Jayanta Mukhopadhyay, Professor of the Department of Computer Science and Engineering and Dean Outreach and Alumni Affairs of this institute, is presenting one of my colleagues in each episode who are internationally renowned for their academic and research work. Today, we will meet a person who is a renowned hydrogeologist and whose mission is to provide safe drinking water to every household of our country, to keep our water bodies and the groundwater unpolluted. Today's guest in our program is Professor Abhijit Mukherjee of the Department of Geology and Geophysics. Abhijit, a renowned hydrogeologist, as I said, is recognized for his work worldwide. He was awarded Shanti Swarup Bhatnagar Award in 2020. He has many other laurels in his bouquet. National Award of Geoscience from the President of India in 2014. Kharaka Award from International Association of Geochemists in 2020. He is a Fellow of Royal Society of Chemistry in UK. He is also a Fellow of American Geological Society. Last year, Abhijit was listed among the top 75 scientists and experts worldwide who are under age 50. So let us meet Abhijit. Abhijit, thank you for joining this program.
My pleasure.
So how did you choose to become a geologist?
I would say that was more of a, coincidence. So, geology is a subject that is not very commonly taught in junior classes. And when I kind of graduated from my secondary school, I didn't do that well. So I was trying to get a good admission in some good school or college, and eventually I got admitted to Ashutosh College, which was also in my neighborhood. By the time when I got admitted, most of the other disciplines got already filled up. So the clerk told me that why don't you get into geology as a fourth subject, and in 1 month's time you can switch it to something else. And after getting into the first couple of classes, I felt that this is one of the subjects I want to continue. So I had geology from my class 11 actually, and as a fourth subject, and then I somehow topped in the whole board, like high secondary board. I topped with a very good grade in the fourth subject. So I thought like this is a subject that I want to pursue. So although my family has a lot of engineers, lawyers, my father wanted me to be an engineer, but I kind of dreamed to be a scientist from my childhood. So I decided to join geology as an honors subject in my bachelor's. And I continued in the same college, in Ashutosh College. Didn't take any exam or anything else in any other places. So just continue with a
It's a very, very strong determination
kind of, yes.
from your side. That's
Kind
great.
of.
That's great.
And then it kind of moved on from there on. So one led to the other, and eventually I ended up doing a MSc in geology, and then through persuasion of some professors, I decided to go abroad and then continued to do a PhD, and here I am today.
Great, great. I see that you did some masters also in software engineering.
That's correct.
Right.
That's correct.
While doing probably while doing this MSc.
MSc, yes.
MSc. So what was the motivation?
So in those days, in the late 90s, the job scenario in geology, and I suppose most of the sciences were not that great. Whereas the Y2K was just coming in, and there was a lot of craze for software engineering and computer science and so on. So just again coincidentally, I saw an advertisement in a newspaper that there is a scholarship that is available for some computer science diploma courses in NIIT. So I appeared in that, and somehow I ranked within the first 300 across the country. And so they really encouraged me to drop my MSc and follow up a computer science career. But my parents told me that maybe that's not a great idea. If I can manage, I should carry it on parallelly. Otherwise, just leave the computer science and carry on with the science. So it was difficult, but I decided to carry on both of them together. So I used to have the day classes for my geology courses and evening classes for computer science. And so eventually, after finishing my MSc, I was also able to get this computer science diploma.
So it was a great advice from your parents and great guidance.
suppose.
So you should be thankful to them.
Absolutely.
doubly thankful.
Yeah, it was a crossroad in my life. So I had to take a decision in half an hour whether I want to leave my MSc and continue in the computer science with this
So
organization.
otherwise you would have lost geologist Abhijit in the kind of routine, I should say, computer engineering stuff.
But in those days it was a difficult choice to make because they were
I understand
assuring a
completely.
job.
I understand
as soon as you graduate.
Particularly in our country.
Yeah, and geology had no future those days,
Right.
unless you go to abroad or something.
Right.
So it was a very difficult choice. So somehow my father said, okay, let's manage to keep both.
But I think that's great, and you could do it.
Yeah,
that is
absolutely.
also, so you had the you have taken that challenge, and finally you see that
And looking back after so many years, I think nothing gets lost in my in the life. Like, that's my philosophy. And now I feel like those courses that I've taken those days, it's now helping the research that we do today. So I had learned artificial intelligence, and at least the version that used to exist those days, and that whatever coding and something I learned in those late 90s classes, now I'm applying those in my research, and my students are doing so.
Yeah. That also I found. I mean, you are applying artificial intelligence, machine learning in your research areas.
And also, I kind of worked with network computing those days.
Right.
So I'm bringing in those old philosophies. I mean, of course, the technology has changed and everything, but I suppose philosophy remains the same.
Right.
So I'm bringing in those network computing technologies and trying to having a network data processing and so on.
Yeah.
So I'm trying to do that too.
Great. So let us listen to your work. So
Sure.
your contributions.
So basically, as you said, I'm a geoscientist. So my basic degrees are in geology. However, when I decided to go abroad, my intention was always to work in something which would have benefit to the society. And out of many of the topics that I could have applied for, I decided to go for working in understanding water, because I feel like water is one such subject where I can make some contribution. Of course, as a student, I had no idea how much I can, eventually end up to. So I had no prior knowledge, but I thought like this is a good subject to eventually go for. Now, unlike what people understand, geology is not just rocks. Like, that's what the common notion is.
Yeah.
And actually, if you look carefully, our society in a big way is running actually on geological resources, because these are the natural resources which would actually keep the society going on, like minerals, like petroleum, like fossil fuel, and water. So there are a lot of other topics that I could have gone through, but water is something that I eventually decided to. And again, just by coincidence, I ended up with a professor at the University of Kentucky when I was applying to the US. I got position in many of the universities, but this was one place where the professor called me from US to discuss with me the topic, and I really liked the idea. And although I had gotten position in some other more reputed universities, I decided to go to the University of Kentucky as a MS student. So while doing that, I realized that the study on water has a huge potential, and specifically for a country like India. So I started working on some problem which was very local to the US, very interesting problem though. But I also kind of felt myself that if I ever able to finish up, the PhD and whatever experience I can get from the US, at some day in the future I should go back to my country, because I think like this is where my contribution, my capability would be of real use. So somehow I persuaded my professor to look for Indian problems, but I persuaded him. We had long drives where we would go to field, because field work is a very inherent part of geology or geoscience. So while going through those long drives in the late evenings and early mornings, I persuaded him to look for arsenic problem in groundwater in Asia and specifically India. So I would do a literature review for him while still doing my MS, and eventually had his consent that I would continue as a PhD student with him. And so I did, and eventually my work was reasonably well appreciated. So I was in the US, but I used to come back to India, to Kolkata and West Bengal to do my studies. And while doing so, I got close connection, I developed close connection with the government of West Bengal, specifically public health engineering. And so both
this was in the year of 2004?
This was 2003 to 2006. So, so the officers in public health engineering and our team, so we worked quite closely all across from Murshidabad to the Sundarbans for 3 continuous years, and the outcome was reasonably well appreciated, and it was quite useful. And I handed out all my whatever I could figure out through my PhD work to the government of West Bengal.
So what are those outcomes? Can you just
yes, so basically, till then arsenic was something that was getting researched. Like arsenic, as you know, it's a poison in the water, because West Bengal, most people are dependent on groundwater, and so is most of the other parts of the country. But in West Bengal, the additional problem is that in the groundwater there is this arsenic. Now arsenic is a natural element, as you know, and it is there from the sediments, so you cannot do much about it. But till those days, people were studying arsenic, but from a very limited perspective, I would say. So they didn't have a lot of clue, like where is it coming from, where is it going. Although there was a lot of research by those days, it was a very hot topic in geoscience as well as environmental science.
They are usually mapping the arsenic contaminated areas or amount of arsenic or something like that.
But since my professor was not in this topic, he had a very different perspective on it. So he and I discussed over many evenings, and we decided to look it from a very different angle. And we started to look at how the arsenic actually is mobilizing through the subsurface through groundwater flow. And now let me just explain a little bit on groundwater flow. So groundwater flow is pretty much a fluid dynamics problem. And just like you will have fluid flow in mechanical engineering or physics, it's the same thing that we also have in geoscience. So I started to look at that, but in addition, with the fluid flow, I also started looking at the reactions, the chemical reactions, that would eventually bring out the arsenic and mobilize it in the groundwater, eventually to the drinking water. So I looked at the flow of the arsenic and its availability in the drinking water systems of West Bengal. And after finishing my PhD, while I was doing my postdoc at the University of Texas at Austin, I scaled it up to not only West Bengal but also Bihar and UP, and also in Bangladesh, and also in Argentina, China, and moving across the board.
What is the depth where these particularly layers of contamination lies?
So initially the idea was, like when I was starting my PhD, the idea was that it is in the first 70-80 meters, and below that the groundwater is safe. And actually, it's a scientific problem, but it has a huge societal impact, because those days the groundwater policy of the state, at least, was getting formulated so that people were moving more toward deeper groundwater for their water supply.
Yeah, we have that 1,000 foot, 1,000 feet tube wells.
About
in every village.
Absolutely.
We had that.
And the idea was that those water are more safer than shallower water. But through my PhD, what I found out, that while that is true more for Bangladesh, that's where the notion came from, it is not true for West Bengal.
Okay.
Because West Bengal has a very different geological setup in the subsurface, which is of course not visible from the top. And because of that very different geological setup, West Bengal has a problem that arsenic resides even at 300 meter depth. Okay. So my study showed that yes, deeper groundwater can be a solution, a sustainable, safe solution, but not everywhere. So where it is not a solution, then you have to go for engineering solution, natural solutions are not available.
That means always there has to be engineering solution.
Not always.
I mean,
You can
in
also-
many areas.
Many areas, yes.
Many areas. So
Right.
you have discovered those parts.
Yes, we did. We did.
Right. So can you tell us what is the kind of physical process that is going on? I mean, in the
subsurface.
in the subsurface.
So-
like what is the source of arsenic layer? What is the depth from where it is percolates?
That's
to
a very good question, and it's a question I would not say that is absolutely resolved till today. So we feel that the arsenic actually is coming from the Himalayas, and
Himalayas.
yes, and this
Okay.
is again a notion that I
That
am
means through
trying to-
rivers it is coming.
Yes, no, but not the present rivers. It's the ancient rivers during possibly the last ice age or even before.
Okay.
So not the present river.
That was kind of very past
It's a
event.
past event.
From where now presently we are
Absolutely.
getting
So
this.
and again, this is a hypothesis that I've been trying to put forth not only for India but across the world, and I've kind of tried to demonstrate that the arsenic actually comes from the large mountain belts, and through the geologic processes, which of course takes millennia, thousands and millions of years, the sediments would come from these large mountain belts and get deposited in sedimentary systems where the sediments get deposited, from where eventually through some geochemical processes, chemical reactions and so on, the arsenic would be leached out. Now this is one of the reasons that you get arsenic only in a very limited space. If you look at the map of India, you would find that the arsenic is only present in a very limited space in the Ganga
Gangetic
basin.
belt.
Yeah, and again that was our initial notion that it is only in the Ganges belt. But now we know that it is not only in the Ganges belt but also in Indus, like Punjab, mostly Punjab. Punjab is largely polluted.
So I haven't heard of that. I mean,
Yes,
but
and
it is
again, that's
there.
that's a kind of a new
So
knowledge.
the Punjab government is also taking care of this.
They just came to know, like only couple of years.
Only couple
It
of
was not
years.
very well
What
known.
about Pakistan?
Pakistan also has a huge problem in this basin,
Okay.
and also the Brahmaputra basin. Assam is largely polluted,
Oh.
and again the knowledge was not available until like 7-8 years back.
And there it was depth was something like 1,000 feet. Or
No, so in those areas, the depth people that explored has been mostly within the 100 meters, to my knowledge. And the reason being that because people were not aware of it, there was no testing, or even they were testing, they were kind of biased, no arsenic, so they would keep it within the first 100 meters. And now through the chemical data that we have been able to aggregate from various sources, we found out that all these areas, like which we call the Himalayan basins, the Indus, the Ganges and the Brahmaputra, the whole area is polluted. But
And the
south of
pollution
that-
came from
the
ancient
Himalayas.
geological ages.
Absolutely, absolutely. And this is some people have really contested that then why don't we get it in other places, only in the Himalayan belts? And that is very specific to some very complicated processes, geological processes that takes in the Himalayas, not in other places. Or even if it took place, it got
But
obscured.
arsenic contamination, I believe it is reported in early 80s maybe.
It did.
That is the first report what we heard.
Absolutely.
Before that though we had no issue of no.
Yeah, so there were some reports, like cursory reports back from 1960s actually, but people were not very aware of, the instrumentation was not there in place.
Achha.
So it was...
But no, see, even people are not aware of, basically the question is that people finally became aware of because it has become a problem across the society.
Right.
It has been observed that there are various kind of, I think, skin disease and others that
yes.
is peculiar. Then the doctors know. From there, people have become aware. So it was not there earlier, I suppose.
Right, and this is where I suppose geoscience and society kind of cross-cut each other. Because in earlier days, as you are from also West Bengal or eastern part of India, you'd know in many of these villages people would have certain skin disease or some health conditions, and people have all these strange beliefs. Mostly thinking like.
So you think that no, it was there, but no,
Absolutely
it was not really diagnosed properly.
It was not diagnosed because people thought either it is maybe even a sin they have done in the last.
What about the uses of water patterns? See the digging earth and getting water from under groundwater from there. I think that was not there in the ancient days. Now we have always used surface water.
No, actually not, because groundwater was actually profusely used even from the days of Indus Basin. Sorry, the Indus Valley civilization. Now it was not very well highlighted, and it was not a very regular practice. But the town of Mohenjo-daro, city of Mohenjo-daro, it is actually called the city of wells because there are more than 800 groundwater wells in the city of Mohenjo-daro.
Yeah, wells were there. Yeah, definitely. I mean, I just missed that point. So wells are the source of groundwater in that way.
Yes.
But not at the depth.
No,
The way even the 100 foot, it was not 100 foot. Usually, it is less than that.
Yeah.
So, will it be something like, I heard that kind of hypothesis, or maybe you also can say that whether it's scientific fact, that no, if you have somehow surface water planning properly and our drinking water comes from the surface water, will it try to address this issue?
Right, and again, that's a very interesting question. You know, like you have to look at the evolution of the knowledge. So till the 1970s, late 1970s, surface water was the predominant water source for public water supply in the Indian subcontinent. But in those days you used to have like these repeated epidemics like cholera, dysentery. At least in our childhood also we'd heard that people would, even villages would get wiped out by cholera. And until very late, public health people understood that these cholera or dysentery are mostly getting caused by ingesting water, surface water, because surface water can get polluted very easily, mostly for coliform bacteria and other sources. So, late 70s, the government of India and I suppose most of the subcontinent governments, they thought that surface water might be a more trickier water to use, and groundwater is possibly a safer source. The reason being that since groundwater is mostly getting recharged from the rainwater and it is going through this natural filtration process because it's passing through the sand and silt, it is a safer water. And this is when I think groundwater as a drinking water source was started to getting used. But then the arsenic came in. So in 1984 it was kind of concretely understood that the groundwater, at least in eastern part of India, do have a lot of arsenic. And since then there have been a lot of research, like I would say, I don't know, maybe 50,000 papers got published. And there are a lot of people who really worked very hard across the world, the best of the minds. And after doing all those things, they now realized that the arsenic is there, you cannot do much about it. It's there, it's a natural phenomenon, right? So now I think the government of India has decided to get back to the surface water. So I work with the government of West Bengal and I know that they're building these huge surface water treatment facilities across the state where they are now taking the water from the Ganga and the other rivers and trying to supply it to the community. However, there is an inherent problem, and again this is a problem that we are coming to know very lately. See, I worked in the US for quite some time and I used to work in the Mississippi basin. Mississippi, as you know, is like the Ganga of India, right? And for a long time, the Mississippi river water was not getting used for a drinking water source. The reason being that through the industrial ages, Mississippi water was so much polluted, not only by metals, but some what we call emerging contaminants like organic pollutions, like hydrocarbons and so on, that the water of Mississippi was not very suitable for use. Now the problem is that arsenic you can treat, these organic pollutants it's very difficult to treat.
Okay.
So yes, surface water is now getting predominantly used, at least in West Bengal, not predominantly, but it's coming in. And I understand through the Jal Jeevan mission there is this focus on using surface water across the country, but I would say that there has to be a word of caution. Organic pollution is just not limited to the US or the European countries, it's also in India. And through one of our very recent studies, I had just a PhD student completing about 2 years back, we showed that the Bhagirathi Hooghly water that we have in West Bengal do have profuse volume of organic pollution present there. So unless we can treat it properly, which is a very difficult task.
I think it is expected now. In
It's
India,
expected. All this industrial waste going in,
industrial
right?
waste, and at the end of your stream,
Absolutely.
you are getting all.
But again,
upstream it may be less.
Yeah, but again, as it says, like ignorance is bliss, right? So the same thing I can see to be repeating again, that people are not aware of it or don't try to, like putting a blind eye basically.
But still things are going on and people are using it. But no, it will affect our future
generations.
future
Yes.
generations. So it is a matter
high
of concern
time, yes,
to consider.
that we should be aware of it and we try to plan accordingly. And
What about this rainwater harvesting? I mean, I don't understand much on that. I mean,
right.
So what is it and how will it be?
So
useful?
rainwater harvesting is something that people have been proposing. Now it's a good technique and it can possibly be used locally at least to hold the water during the monsoon time. At least in the eastern parts of India, we have a pretty big monsoon and we have a lot
So
of water.
hold the water where?
Okay, so initially people were talking about holding it to some subsurface tank or some container.
How
And
many
then
days it can be there?
It can be there, but there are other problems. I'm coming to it. Sorry, in a minute. Then they decided to hold it into ponds,
Ponds.
and the.
So that is natural way of storing rainwater. I mean,
Right.
we dig pond and
Right.
you get
And
water there. I mean,
Yeah, so the Manrega program, like one of the focus had been to build these ponds,
Ponds.
or dug these ponds.
So that
and
is what rainwater harvesting.
that's pretty much in motion.
Yeah.
Now, unless it is a pond, if you are trying to store it in an underground tank or something, there is an inherent problem. Now, see, like being a tropical country, we have all these vector diseases, right? Like mosquito-borne and other insect-borne diseases. And there is a possibility
That
that these underground tanks becomes a kind
Den
of
of-
like
den of
incubation
mosquitoes.
center for these vector diseases.
Yes, that is.
And there are studies which shows that it is actually happening.
I heard that another way of harvesting is that you just take the rainwater when the raining is there into the deep soil,
Yes,
something
people
like
have been
that.
proposing
Is it
that.
is it useful or is it?
Well, experimentally it can happen, and I suppose in some places they are trying to do that. But to my understanding as a geoscientist, as well as somebody who has worked in the field for so many years, it is not like a wide-scale practical application. I mean, in some places you can possibly try that. It might work. It possibly would work. But it does have a lot of limitations. And maybe in a longer scale or in a larger spatial scale, it's not a very bright solution.
Okay. So it's really, Abhijit, you are deep into this problem, and as I could see that, it's a very challenging issue, but
Yeah.
the question is on our survival.
Absolutely. So,
so
I would just try to bring out one more side of what we do. So I had started with working with the water pollution and the water quality, but eventually I learned, and this is what my postdoctoral supervisor used to work on, and now I have also kind of started working on that, to look at the groundwater quantity. Now, in being in West Bengal or getting born in Calcutta and growing up in West Bengal, we never had a water stress problem too much. I mean, I understand the western parts of the state do have water crisis, but at least in the eastern part, we don't have a lot of water crisis problems. But in the more recent days, you would see in the newspaper, in the media, that large part of the country is actually reeling through severe drought,
yeah,
mostly in the summer
particularly in
times.
Vidarbha region.
Absolutely. So I started looking through some of my students, and then I had some collaboration with NASA, and we worked very closely even today after 10 years. And we started to look at the groundwater condition across the country and across South Asia actually, but specifically through India. And we realized that while quality is an issue for many parts, quantity is also a very big issue. And again, see, like if you want to get a volume of safe, sustainable amount of water, you need to have both quantity and quality. So either of them is not sufficient.
No, yeah.
And now what I'm trying to look at is we're trying to quantify the volume of groundwater that is available. We're also trying to quantify the quality of the water that is available, and trying to see the net volume of safe water that would eventually be available.
So it would be used for planning and
Absolutely, absolutely. So I have been an advisor to the Ministry of Water Resources. Now it's called the Ministry of Jal Shakti in various capacity, and also I've been working with Jal Jeevan Mission in advisory roles and so on. So I've been trying to, propagate my outcomes, science outcomes, to the planning stage, and I think that's where it can make some difference, because the research outcome that we can bring out from these research projects can eventually be translated to policy making. And I'm quite happy actually, because not that I had a lot of hope, but in the last 5 to 7 years, I've seen that several of my research outcomes have eventually have taken attention in the ministry level, and in some way or other they are now getting implemented or at least propagated through various planning measures and getting used across the country.
It's great to know.
I'm really pleased.
And also the government of India is taking your
Government of India, Government of West Bengal, Government of Odisha.
Your expertise and research work.
So and that's very satisfying in a sense that as a scientist, both you and I realize that publishing paper is a great thing, right?
Yeah.
We all do. But that is one aspect of a scientist. But when we get to see that the same science is also used for betterment of the society, I think that
is more satisfactory. Another level of satisfaction.
Yes, absolutely.
Yeah. Another thing I would like to mention here. So we heard about your project Varanasi,
yes.
And you did wonderful job.
Thank you.
Can you just briefly state what
Absolutely.
you did there?
So the project Varanasi that we were working on, it was a project, a part of a project, larger project called Sandhi, that was headed by IIT Kharagpur from 2014 to 2019. And the mandate of this bigger project was to look at the heritage of India through a lens of science. So when I was given this project to lead the project Varanasi, I was not very aware of what I'm supposed to do. But eventually I realized that heritage is not just looking at history, but also to look at the future. So Varanasi, as you know, it's regarded as one of the oldest living city in the world. And we all agree that it is a city where the past and the present are kind of coexisting.
How old it is?
People believe that it is contemporary to the Indus Valley civilization.
What is the archaeological evidence says?
So we saw archaeological evidences up to about 3,000 years.
That means 1000 BC.
At least 1000 BC, or even more than like 1500 BC. 1500 BC. So yes.
So that is your findings, or others have reported?
Both. So when we are giving this project Varanasi, initially I was a little perplexed, like what I'm supposed to do, and then I realized that being a geoscientist, I think I have a big contribution that I can make to try to understand the framework why the city of Varanasi was initially constructed in that place where it is today, and why it survived through all these ages, and how it can survive in the future. And again, coincidentally, it was around the same time that the Prime Minister announced Varanasi to be one of the future cities of the country. So it's one of the smart cities. So I think it was another momentum that we got, and we decided to develop the project Varanasi to be one of the first, what we call urban geoscience project of India. Now again, this is a new concept. It is practiced quite widely in Western countries, where we try to understand the natural resources of a city to make it resilient, both for the present times as well as possibly the climate change scenarios that can happen. Now Varanasi being a very old city, kind of having the very old infrastructure, but also looking for the future to become, one of the kind of iconic city for the future, where the past and the future can coexist, we decided to look for the subsurface of Varanasi, try to understand its interaction with the Ganga river. Ganga is kind of the part of the city itself, and also kind of try to understand what can happen to Varanasi if there is a natural disaster, like an earthquake or like a huge storm coming in. So eventually, and the British Geological Survey, we worked very closely with them, and they are a world leader in urban geoscience. So they become a partner to our project, and we together kind of developed a very detailed, subsurface understanding of the Varanasi, the natural resources of Varanasi, and we kind of advised like where construction should be made, should not be made, how the river can be sustained and can be survived for the future times, how the groundwater of Varanasi and the river water are interacting and either getting polluted or can be treated. So it was a very encompassing project. It is just not only one aspect, but trying to understand the present of Varanasi and making it a safer place, sustainable place for the future times.
Are they being used presently, your findings?
Well, I think they are used in parts. I would not say that it is getting used all together. But yes, we had communicated our information to the PMO, to the Varanasi municipality and the state governments. And I understand that parts of our research findings have been used. Not in all. I think there is a much more information that are available with us, which I would be very happy to share. But I am hoping like it will be used for the future times.
Okay.
But it also was a kind of eye opener, like what a, and this is the brand new branch of geoscience. It was not very well practiced even 10 years back. So this is a very brand new branch of geoscience.
So similar studies should be carried out in Calcutta and many other metro cities.
So we actually talked with the Rajarhat Development Authority, and I was also approached by Bhubaneswar Authority if we can do that. I know British Geological Survey is helping out Amaravati, which is the new capital of Andhra Pradesh. So it is a new concept that we could bring in, and we hope that this can be brought in a very big way for the resilience of the Indian cities for future.
Great. So we heard about, you told about your school days, and so who are most influencing persons for you to become a scientist and professor here?
Again, like I always had this dream that I'll become a scientist, not possibly knowing what it means. So I had this inclination of learning science. Now I would not say I was a very good student, but now looking back, like what I feel personally, and I always encourage.
You say you are not good student, but you said that you you got within 300, etc. So maybe in school days you did not perform that well in marks wise, but you are a very good student, no doubt.
No, I would not say that. But what I understood, like after all these years, that in the pedagogy that we have in our school structure, where it is more more memorizing, right?
Right.
And I have not been a very good at that.
Very good at memorizing. That is okay. That is understood.
And that's where all the grades are in the school days, right?
Yeah.
So when those days are over and it was more open and more based on concepts and philosophies, I suppose that's when I started getting ideas.
Right.
And I could.
You are enjoying your studies more.
Science, yes, absolutely. So when physics or chemistry was not just something that I learned in the books, then I started kind of relishing it.
Right.
So I would say, like, in addition to my parents, of course, one of the influencing.
So what are they doing?
Okay, so my father is a mechanical engineer, and he was working for the government of West Bengal throughout his career, and my mother is a homemaker.
Yeah.
Now my grandfather was a very renowned lawyer, but I lost him like when I was very young. But even when I was very young, he used to tell me that you have to become,
scientist or lawyer,
something
great, something great.
Out. Yeah. And my grandmother, now she was even for those old days, like she was a convent-educated lady and from a very well-to-do family, from the Raishai families of the British times, and she was quite learned actually. So she actually encouraged me to go abroad, even those days. And she was also quite an influencing character. And the other couple of people that I would like to mention that who did influence me in my very early career, I had a cousin, like a few years elder to me. He was very interested in science. Now he never became a scientist himself, like he went to more spirituality. But in those early days, between brothers, we used to do chemical experiments. So I had a small chemical lab. Yeah. And those days, even like when being a school kid. So that was, I would say, something influencing. As well, my uncle from my mother's side, my Mesho, as you call it. So he was possibly the most prominent scientist in our family. So he was also a Bhatnagar laureate in 1997 in nuclear physics.
What's his name?
Bikash Kanti Chakraborty.
Yeah.
So eventually he became the director of Shah Institute of Nuclear Physics. Right. So even though we were very scared of him, like he was this big scientist, and we were just kids those days. But I suppose in the background, I think like those things also did play a role. Right. So it's not that I really planned my career, but it happened in a good way, I suppose, and it eventually one led to other, and that's where I am today.
So why did you join IIT Kharagpur?
Okay, so when I decided to come back to India, and after I was in North America for about 10 years, like studying and then working, I was always having this dream to return to my country and work here, because I thought that's where I can contribute. So I had applied to a couple of places, few places, mostly IITs and IIT Bangalore. Now I kind of had an offer from IIT Bangalore too, like before I got an offer from IIT Kharagpur. So I was already working there and leading a project, and so they wanted me to join immediately. So I had to gently and respectfully decline, because I had to finish that project before I can come in. And it was around that time that I got this offer from IIT Kharagpur, and I was also finishing up my project that I'll transition to the next project. I had a permanent position, but it was still, my responsibility to finish that project. And looking everything together, IIT Kharagpur is one of the most reputed institutes in the country. It has this long, heritage of serving science.
Particularly the geology and geophysics department is very well
known. Yes. So now I didn't have a lot of knowledge, but I came to know from my colleagues and some of my teachers that the geoscience department, the geology and geophysics department of IIT Kharagpur is one of the best in the country, if not the best. So I thought like this is the perfect place that where I can end up. So in 2010 I packed up my bags, literally packed up my 10 years of North American life in 6 suitcases and returned back.
Great. So, how did you find after joining?
Yes, so just like I suppose for most people who would come back from other countries after a longer duration of stay, the initial days were a little, I would say, hectic. But
getting accustomed with the work culture here.
Work culture, expectations, and I would not say everything was bad. There are a lot of good things. Being in North America for a long time, I had this impression that in India, if I return, like most of my work would be only limited to numerical work, because instrumentation would be a problem. But when I returned back, I was very pleasantly surprised that at IIT Kharagpur, even in our department, the instrumentation that we have is not only comparable, but possibly even better than many US universities those days.
And also, I think your academic program is one of the best. You have regular field visits and
absolutely.
Many renowned geologists, they came.
Right, absolutely. So, so I have been to some of the best universities in the US, but I found like here there is equal or even better merit existing in our department and in the institute. So those are very good, very good notions and memories. But also there are some challenges of obviously initially adapting to the government system and the purchasing and all this thing. But I suppose I survived after all these years, and I have all positive memories, I would say. I mean, of course there are small hiccups there this way and that way, but I suppose that made me a better human being and a better person. Possibly made me understand the intricacies of the system in a much better way, going through those issues. So after now it's almost like 12 years.
Don't you miss your metro life? Because what I understand, you are born and brought up in Calcutta.
Right.
Then you went to US and Canada, and you lived in a big cities. It's a very, I should say, rural setup.
Absolutely.
Not much of metro facility.
No, so I've been trying to balance my life. So my family actually stays back in Kolkata, so they don't stay here.
Sure.
So over the weekend I do go and visit them. So
okay.
I've been able
that is how you are balancing.
Yeah, I've been able to keep the rural balance in the weekdays and the urban balance in the the weekends. And it has been almost 12 years and
12 years.
No complaint.
Yeah, actually, when you joined already this highways, etc.
Yeah.
They have
the
become
train system.
They train and highways, all those things have come.
Absolutely. So
yeah,
it takes
communication was not that difficult. 2.5 hours communication,
right.
so it is manageable.
Like 3.5 years. Like I stay in southern parts of Kolkata, so it's quite comfortably reachable.
But your family must be missing you very much, no?
Well,
only in weekends. Your how many your kids how they are managing you without you?
Well, they grew up. I mean, not they. Like I have only one daughter.
Yeah.
So she grew up. So when I returned to India, she was 3 years old, and now she's about to sit for her Madhyamik exam next year.
Yeah.
So time flies, and See, like in life, there are always ups and downs, and
Right.
we have to balance through
So
that. Right?
your wife is also working?
Well, she is a professional singer. So
great,
she is a classical Hindustani classical singer. So she has her like lessons. Her gurus are all in Kolkata, and she also takes like teaches students. Her programs are in Kolkata, and she's actually, talking about Varanasi. She's a Varanasi Gharana classical singer.
Great.
So again, talking about balancing life. So while doing research in Varanasi, my wife also accompanies me and takes her lessons from her gurus in Varanasi. So it all eventually works out.
Yeah. So you take your family in your field work also?
Yes. I and that's how I make up the time actually. So even from very early days, like when my daughter was quite tiny actually, I used to take her to field to give her the feel what's outside the book. Like again, she was born in the US and she was born in Texas, and we came back when she was 3 years old, and so ever since she has been growing up with us here and in the Indian system. So she have gotten adjusted to the Indian learning process. But again, as I said, it's very pedagogical and very memorizing kind of thing, right? So I try to take her outside the book and show what the real world is, how the physics and the chemistry works in real life. So I suppose she enjoys. Sometimes complains that I travel too much on the sun, in the field and so on.
Right.
But yes, I definitely take her and try to get her involved in the work that I do.
Right. So Vijit, it's nice to talk with you of
it's
so many things. So before we wrap up this program, so any message to our viewers, particularly to the young generations?
Absolutely.
And as a geologist, because now the craze of whatever you see that in JEE exam, always top 100, they always try to, or top
Right.
within top 1000. So there is a craze for computer science, mechanical
Right.
engineering. So any message from you?
Yes, so I
regarding
would say a
that?
couple of messages,
Yeah.
if you may permit me. So the first thing is, among the applied sciences, geoscience is one of the topic which is not very well highlighted. But if you go by pay package, geoscience graduates do get a quite lump sum pay package, because many of these people would work in the petroleum, like the fuel industry or the mineral industry, and there the pay is quite high. So if somebody is very excited about the money part, that's where it is. But beyond that, it is one such subject where you get to see the nature. We get to interact both with the natural setup, in terms of the mountains and the rivers, also work with the society.
It's a very enjoyable life as a scientist.
Yes, if you want to live out in the nature and have, it's more of an adventure, I would say. Like the adventure books that you used to read in our childhood, I think I'm living that through my profession. So that's a very positive thing, and I always encourage my students to have that kind of a feel like when they are out. So if that is one message I want to give, but I would also like to say specifically for the IIT entrants, that graduating and getting a job, of course, is a very attractive thing to do, and I'm sure you and I both had those opportunities in our early days. But these kids are some of the best minds in the country, and now that we aspire to be one of the most developed country in the world, in the top league, I think they also have to come forward and definitely, not only just get through the pay package, run after the pay package, but also contribute to the science and do their PhD, possibly contribute to the betterment of the society. You cannot just blame that nobody else is doing it, so why should I do it? So I have been telling my students, and fortunately enough, been able to influence some of my BTech and MTech students here. So some of them decided to join PhD with us. So they are doing, some of them are PMRF and so on. So if that's the second message, and the third message is, when a new student would join to me in a PhD, and they said, "Sir, what should the first thing I should be learning?" I know it's a little striking, so I tell them that I would teach you how to fail. And obviously that's a little astounding for them, and they get really perplexed. Then I explain them that everybody talks about the success and what they can do through success, But I personally feel, and I think I learned it through my life lessons, that unless you fail to do something, you don't learn properly.
Great. I think that's a very
Yeah,
beautiful lesson.
And I think failing is not of something of shame. I mean,
Yes.
I think it's good to fail in some sense, because that failure actually makes you to understand what you have done wrong, and possibly how you can do things better.
So you should have a positive mind.
Absolutely.
You should have a positive mind on your failure.
And what I really tell them that, see, there is no shame in failure, but there will be a shame if you don't learn anything out of it. So the next time you do it, you should do it better way.
That's right.
So, just being a computer scientist, the loop that we run in programs, right? It's pretty much a loop exercise, right? So when you run the loop again, you should have a better estimate.
Right.
So I think the failure actually makes you a better scientist. And I always encourage my students to fail, initially at least. But down the road, I've been quite fortunate that they have done wonderful work.
Wonderful. So once again, thank you very much.
Thank you. It's my pleasure.
Wish you all the best. And
really
as we said that we are very proud and happy to see
you.
that you are doing such excellent work. Our country is reaping benefit of your expertise.
Thank you.
And looking forward more from you.
Thank you so much.
Thank you very much.
Thank you.